Hello friends, welcome to my channel. Let's have a look at today's daily challenge problem. Problem 129. Sum root to leaf numbers. In this video, we're going to share several formats of solutions based on traversal. This problem actually is very routine. Therefore, we are going to practice traversal, and here we are going to present two ways of getting the number and present some small tricks in coding. First, let's look at the problem statement, and then we look at the coding and explain them line by line. First, the problem statement. We are given the root of a binary tree containing digits from 0 to 9 only. So each root to leaf path in the tree represents a number. For example, the root to leaf path is 1, 2, 3, right? So this will represent the number 123. So here our task is to find and return the total sum of all root to leaf numbers. So in other words, if you have 5 leaves, then we are going to have 5 root to leaf numbers, and we need to sum them. So the test cases are generated so that the answer will fit in a 32-bit integer. So that's not very essential for the coding. So a leaf node is a node with no children. So here are two examples. So let's look at example 1 because this is much easier. So we have 12, we have 13. So the overall sum is 25. So in example 2 we have 495. And then 491 and 40. So you add them together, you get 1026. So the constraints for the problem are the following. First, the number of nodes in the tree is given by the closed interval 1 and 1000. And the node values are digits. And the depth of the tree will not exceed 10, right? So this is the problem statement. So now let's look at our plan. So here we are going to present two ways of getting the numbers. So one is to use type conversion, and the other is use the cascading of multiplication by base 10. For the first choice, so we can store the root to leaf string. So for example, 1, 2, 3 is nothing but 1, 2, 3, and then we call int. We can see we apply this function to this string to get the corresponding number. So this way is sort of brute force. The second way is that we're going to do cascading multiplication. So for example, if we start 1 and then we move to next subtree root 2, then originally we are going to have a number 1. And then if we get 2, so what we are going to do is to multiply 1 by 10 and then add 2. And then from 12 to 123, so we're going to multiply 12 by 10, then add 3. The reason is that so each time we go to next level, then it corresponds to push the number to the left a digit correspondingly. So this corresponding to multiply by 10, right? So we add the current value. So this is the second method, or second route. So with that said, let's first look at the version 1. So it's here. So in version 1, basically we use traversal plus type conversion. So this actually is just represents one treatment. So for example, I'm going to initialize a variable called result as it's going to be 0 at the very beginning. So we are going to return this variable state and after we do the traversal. So in order to do the traversal here, we can use iterative format. So notice that the number of nodes in the tree is at least 1. Therefore, this root represents a non-null tree. So we can do like this. So let's use depth first search maybe. So here I'm going to store root, and also I'm going to store the current root value, right? So it's root value, but I'm going to store it in a string format. So here, this string is the root to the current node string. Right. For example, the root is just itself, right? And then the string is root to node string. Then the traversal process is very routine. Let's do it. Well, as so first I get a node and we get the string, right? It's s pop. So what we are going to do is to check if the current node is a leaf. So if leaf, so we are going to do a type conversion to this string and then add the result to the result variable. So this is actually very standard. So if not node left and not node right. So what we're going to do is going to increment the result by integer of the current string. So notice that we know that the add operation has higher precedence than the not. So in principle, you don't need to add the parentheses here and here. But in order to make the logic clear, so we added the parentheses just for clarity. So after we did this step, so we can look at the else block. So either at least one node is not null. So for this case, so let's do this. If not, root right. Right, here I'm adding right first, and then do left. So this corresponding to a specified order of traversal. So here, what I'm going to do is to let's see. What we're going to do is as append. So I'm going to add node right, and then the previous string then incremented by a string of the current node right value. So this is what we are going to do for the right subtree root. And then similarly for the left subtree, I'm going to copy this line and make some modifications. In other words, I'm going to change this right to left and here. So this piece of code represents the traversal process. After we do the traversal, we can return the result state. So this short piece of code forms a solution format to this problem. So here, actually, in the process of traversal, we add this piece of information to retrieve the root to leaf integer value. So after that, so we can just return the result. So before we make any comments, let's first do a check. Yeah, it passes the second example, I guess. Now let's look at generic case. Yeah, it passes all the cases. So let's regard this as version v1. Now let's copy this one, and then we just modify it to make it another solution. So I'm going to change this function name to be v1, and here let's call it v2. So here what we're going to do is like this. So we can actually copy all of this. So what we are going to do is we store the root value here, right? So now the root value is an integer, right? So if the value is, so here I'm going to change this to be value. Just so if it's already representing a root to leaf value, I'm going to increment that value. So when we do the append operation, so what we are going to do is not doing like this, right? So what we are going to do is 10 times the previous value, then plus node right value. That's the one. And the second part, so let's do the modification. So we can do 10 times value plus node left value, right? So now what we are going we store is just here the value will be the root to node value, right? So if the node is a leaf, so we are going to increment the result. So this is another solution format. So here is cascading multiplication, right? So let's check to see if our modification is right. Yeah, it passes the second example. Now let's look at the generic case. Yeah, it passes all the cases. So this is another solution format. So here I want to copy this one and present some other format just for fun or for some coding tricks. So let's regard this one as v2, right? So now what we are going to do is I'm going to initialize a variable, and then I'll write a traversal function. So I'll define traverse. So we're going to accept a route. Roughly, this is the code, right? So, but here I want to modify this result. This result is an out loop for this one. So here the result I'm going to use let's see, I'm going to use this non-local keyword, so that because result is the integer, is this variable is immutable. But in order to, if we want to modify its value using this worker, let's see, we non-local it, and then we can do the same. So what we are going to do now is to call this traverse function, right? And then we call this route. So notice that in this function we return nothing, right? So then we can check this format. Let's call this v3. Let's check. Yeah, it passes the second example. Now let's look at the generic case. Yeah, it passes all the cases. So this is the one way, so we treat that. So another way to do this, let's call this one v3. Let's copy it. And let's call this one v3. So for this one, let's call it v4. But for this version, I'm going to use the attribute. So this way, this attribute can be modified. Then I'm going to delete this line, and then what I'm going to do is to change this one to be the attribute. And then what I'm going to do is, after calling this function, is self result. This actually is another format. Let's check. Yeah, it passes the second example. Now let's look at generic case. Yeah, it passes all the cases. So with that, this done, it's almost it for this video. Let's give a quick summary. So in this video, we presented two formats of solution overall. So one is based on type conversion, and the other is based on cascading multiplication. But all the two options are driven by the traversal algorithms. So here I'm writing the algorithms in an iterative format. So actually it's also good practice, if you like, to write these examples in a recursive format, using, in other words, use recursion. So with that said, I guess that's about it for this video. Thank you.